Hello everybody and welcome back. This is going to be our final section here, putting it all together into coastal landforms. So things like waves, tides, all come together, right, in order to shape the coastlines. You can see how this works. Right? Biggest thing you want to know first off is this an active margin, plate boundary, tectonically active area, or passive margin, not active area. You get totally different kinds of coasts, uh, depending on what's going on there tectonically, right? From rocky areas or passive areas with big, long beaches, lower energy places, swamps, to mountains right there on the coast, right? Depending on where you are. Two major types of coastal morphology. Morphology just means shape, right? Coast shapes. We've got active margins, which tend to be dominated by erosion, passive margins, which are dominated by deposition. So let's get started. Start with the active margins. Right? Going to be closer to the plate boundaries, with the leading edge closer to the action. Right? Going to be high relief, so steep, rugged topography, a lot of exposed bedrock, exposed to the elements, steeper slopes, higher elevations right next to the shore. These tend to be erosion resistant, hard rock sticking out. The type of rock and how well it's put together all plays a sort of factor here, but a lot of variables involved as far as how quickly it erodes. And a good example of this, west coast of North America and South America too. Right? So we can look at some of these landforms. Right? We have this blowhole here, right? So water comes in and finds a little soft patch of sediment maybe here, and erodes it really quickly. And so wave rushes in and has nowhere to go but up. See this circular carved out bays and beaches. So waves hit here and they get slowed down dramatically, right? A lot slower water moving here in the bay tends to pile up sediment here and sort of eat inland, form a little beach here. You have these little things called sea caves, so there might have been a little softer or weaker patch of sediment here. It's getting eaten away, curving in a sort of circular motion, just like we see with the bays, but of course much smaller. These bridges, right? If this kept eating through all the way to the other side, it would form this little tunnel, and on top would be a bridge. And if this goes on long enough, the bridge collapses, and you have these totally different independent sea stacks sticking out here. And now the whole thing put together is called the headland, kind of sticking out into the water, like over here with the headland. You can also have these cases where you have these wave-cut platforms, sort of flat areas, right next to a pretty pronounced cliff. And the mechanism for these, the cliff was originally, maybe way out here, but it gets undercut by the water. Stuff that's down low gets eroded until the stuff on top is just not stable, and so it comes crashing down into the water. This happens over and over and over again. The cliff retreats, and we are left with this long, broad sort of platform here. So this cliff, at one point, was sticking all the way out to here, but it just kept getting undercut by the water. Undercut all the way down to here. The top falls in over and over and over until it recedes back like this. And so, if this is an exam, and I show you this photo, you should be able to determine pretty high likelihood what kind of coastline you're looking at here, and be able to say, okay, well, I recognize this feature, I see this sort of curve, I see this sort of rugged topography going on over here, so I know what kind of coast this most likely is, what kind of margin. Moving on, passive margins, dominated by deposition, going to be on the trailing edge of plates, a little bit further from the action, lower relief, nice flat, wide coastal plains. These are going to be dominated by transportation and accumulation of sediments, right? So, before we're eating stuff away mostly, and here we're building stuff up during the passive margins. Of course, it's going to experience some amount of erosion. It's never going to be purely just sediment deposited. It's never going to be that simple based on different factors. Sediment supply changes over time, sea level changes over time, but dominated by deposition, right? The deposition is the bigger factor here, like on Atlantic coast, East Coast, Gulf Coast. Right? Sand transport is most of the sediment that's going to get moved around here for our purposes. Right? We started talking about beach drift. And the sand moves along the shoreline in and out due to the wave motion. But for this particular part of it, the beach drift, we're constrained to just the beach itself, as opposed to longshore drift, where we might move off the beach and actually into the water. So as a result of the combination of waves and currents and wind and all these other factors, we have movement along the shore. It's called longshore drift. And it tends to move sand out into the water past the beach. And we'll go ahead and give you an image here. So waves come in this way, and then when they come back out, they don't come back out at an angle. Right? So they come in at an angle and push the sand up here, and they come out sort of perpendicular to the coast like this. And this happens over and over and over again. Right? And as a whole, there's this net movement of sand grains in this direction, longshore current direction. And you wind up with all these sort of landforms, right? So the longshore current is going in this direction, right? So waves come in like this and push the sand out even past where the land is, and then out. And then they push the sand further out and then back and push it further until you develop this whole landform here called a sand spit, sort of sticking out, hooking past the actual landmass itself, the mainland, and making a little bay as a result. You can have things like barrier islands, right? Sort of parallel to the mainland, blocking everything in here, right? Forming a barrier between this and the more wild, rugged, higher energy ocean here. Sometimes develop a lagoon behind these, so kind of slow-moving water, lower energy, not quite the same as something that's going to be exposed to all the elements here. Develop all these little landforms, and we'll actually go through them one by one. So first, right, a spit, like we see right here, sand spit. So if there's kind of an extended stretch of beach past where the beach would normally end, going out to sea, joined to the mainland at one end, just like the example here. Right? So we have our mainland here. You can imagine the longshore current is going in this direction. You see the mouse cursor moving, and it pushes the sand further and further in this direction to form this spit all the way up till here, long, skinny, sort of hook shape. And sometimes it's a combination of a lot of factors, right? Longshore drift is in this direction, but maybe the wind is going in this direction to the left. It actually starts to curve around here. Still a spit. You could also have, it's called a bay mouth bar. So this is like a spit, except that it's at the choke point for the bay, right? It's controlling access of the water going into the bay. So this is sort of like a spit, except it's right here at the mouth of this bay here. Sort of like a spit, maybe the longshore current comes up like this and starts pushing it out. But because it is controlling access to the bay here, right, it becomes a bay mouth bar. We also have barrier islands. The mechanism for how these are formed is complicated and just not completely settled science-wise. Could be a good pack-back question. Yeah. But you have these elongated, long, skinny islands of loose sand, usually, which are parallel to the shore. So it's kind of hard to see here, but this is actually the mainland here in the background, right? And running parallel to it is this long barrier island, a barrier kind of protecting what's here from all the energy of these waves and everything acting. Right? And it's kind of hard to see here too, actually, but here's the mainland in the background, and running parallel to it is this big old barrier island, long and skinny. Finally, you have beaches. Everybody knows what a beach is. And these narrow, gently sloping strips of land that are going to be along the edge of touching an ocean or a lake or a river too. Those are also beaches, right? Maybe a passive margin here, just based on what we're able to look at, this broad, flat beach. Maybe a different kind of beach here. A little bit more of a curved shape, like you saw with the active margins. A little bit less beach, a little bit more steep to it. And finally, you have these things called tobalos. Right? So you have this little sand bar, this sand stretch, sand line almost, joining an island to the mainland. So here's our island, here's our mainland, and here is tobalo in between, this long, skinny stretch of sand. We've got our island, and our mainland, and we have tobalo in Okay, so what are the big ideas for this section? First, coastlines, east-west, what's the difference? Active margin, passive margin, what's the difference? What's the shelf, slope, why are these important, how do they all tie together? What are the difference between the active and passive margins? In detail, could you tell the difference between one and the other just looking at them, right? Just from an image, be able to tell the difference. Currents, what are they? What are the predominant patterns, and why do those patterns exist? Spring tides and neap tides, right? A long discussion on this one. What are they, and why do they happen? Why are they important? And finally, well, we have our different coasts, right? Erosion-dominated coasts and depositional-dominated coasts. Finally, all the landforms that are associated with each. Have a good one. Thank you.